And so today we are talking about fronts. So, what exactly is a front? Well, a front is essentially a boundary between different air masses. And typically, air masses have a consistent temperature, a consistent dew point. So may not be the same temperature, but it's an area of similar like air conditions. So when we talk a little bit about air masses, we're talking about these different types of areas all around the globe that have similar temperature and dew point humidity. And there are air masses all over the globe. And this map here that you see kind of outlines all of the different air masses that we have in North America, at least. So over us in New Hampshire, we're typically in we're kind of in between a whole bunch of different air masses, but more typically we're in what we call a continental air mass where we have temperatures that are more moderate compared to the continental polar or the continental tropic. But because we are sort of in between that and even maritime polar, we are in a pretty typical battleground. So that's why we do tend to have differing weather conditions frequently. So we have a lot of changes. It's not like Southern California where they have kind of the same weather, or even Florida where they have the same weather all the time. So because of these battles between air masses and who's going to win, who's going to lose, that's why we do have a lot of changeable weather, because along those boundaries between air masses is where we have fronts. So there is also importance in knowing a difference between high and low pressure. So let's first talk a little bit about that. So when you watch me do the weather on WMUR or any meteorologist, a lot of times you'll see these big blue H's and green and red L's on the maps, as you see on that map there. So low pressure happens when air is converging around a low pressure center and then it's forced to rise. So and as it rises, it cools, and as air cools, condensation begins to happen, and you form the clouds and then eventually precipitation. So that's why we associate bad weather, or at least stormy weather, with low pressure systems. So a couple of examples of more well-known low pressure systems: nor'easters, hurricanes, really any type of snowstorm has some sort of low pressure system associated with it. So low pressure we typically associate with stormy weather, with bad weather. On the flip side, we have high pressure, and what's happening with high pressure is as the air spreads away from the high, so the air moves in a clockwise motion, but it spreads away, air sinks in to replace it in the center. And as sinking air warms, the evaporation begins to exceed condensation, which means that clouds will just tend to evaporate, or they just won't form. So that's why fair weather is often associated with high pressure. So high and low pressure are very important for meteorologists when forecasting the weather and figuring out what we have going on and what's going to be moving in. So next up, let's talk a little bit about fronts. So as I mentioned, fronts are essentially a boundary between differing air masses, typically between warm air and cold air, also more humid air and then drier air, moist air and drier air. So a cold front, and that's kind of what it looks like there with the little spikes. It's the location of the leading edge of a cold air mass, which is displacing a warmer air mass. So sometimes you'll hear meteorologists say ahead of the front or behind the front, meaning that the temperature is either warmer or colder depending on if it's ahead of the front or behind the front. And also remember that the terms cold and warm are all relative, of course, because like yesterday, for example, I know we had some thunder and lightning at my house and hail even. That technically was a cold front, even though the temperatures outside were already cold. I mean, at my house, I think it was like 38 degrees and we had those thunderstorms coming through. But then it did get colder following that system. So it is all relative. You can have a cold front come through on a 90-degree day. You can have a cold front come through on a 38-degree day like we did yesterday. But always behind the front, it is colder than the temperatures were previously. Now, the opposite, of course, is a warm front. And we denote a warm front on our weather maps with the little red humps there, as you see. It's the leading edge of relatively warmer air, and it replaces a colder air mass. So like a warm front, it tends to extend from the center of a low pressure system, but it's almost always on the east side of the low. So we're going to take a look at how low pressure and fronts kind of look on maps. But typically a warm front precedes a cold front. It can be days between the warm front's arrival and the cold front, but typically they are somewhat associated with each other. Cold front almost always seems to be like the grand finale as the low pressure system is moving through. We also have what's known as stationary fronts, and this picture here shows you that they are denoted by both a red and a blue spike, which essentially means the front is not moving. We do tend to get these here in New England, where a lot of times low pressure systems kind of ride along stationary fronts, and they are typically the dividing line between colder air to the north, warmer air to the south. And so it's a difference of the wind direction and the temperatures. That's what this boundary is, the line is for. You also might see this line and these symbols. This is called an occluded front. Now, occluded front is what happens when cold fronts typically move faster than warm fronts. So there are times as the low pressure system is kind of evolving and actually maturing that the cold front will meet up with the warm front. And it's forced into what we call this occlusion. And the surface location of an occluded front is usually at this convergence point of the warm and cold air masses. But the occluded front kind of extends out between where the warm front and the cold front is. We call that the triple point. And then also on the end of it is where the center of the low pressure system is. So occluded fronts, generally, I see them when we have a mature low pressure system, or even when the low pressure is kind of, when it's dying out. So that's a look at the different types of fronts that we have on surface analysis maps. Now, also important to note when we're looking at surface analysis maps is surface weather data. And again, I'm going to show you a real life map of fronts and also surface data in a second here. But all across the globe, really, there are what we call ASOS stations. So those are automatic surface weather observation stations. I even have one at my house, actually. So if you follow my Facebook page here, I had posted a picture last night of my weather station's output and what it was showing as the thunderstorm was coming through. Well, weather stations are literally all over the globe, and they're always collecting live data. And that data actually is fed into our computer models, and it helps us forecast the weather even better. But surface weather data is also helpful to look at just to know what's happening right now. And the way that meteorologists look at surface data on a map is by using these little surface weather plots here. So typically there's a little circle, and the circle is the sky cover. So if it's empty and it's just white, that means it's completely clear. And as as there's more cloudiness, or if it's overcast, it fills in that circle. You also have a wind barb on there. You have this 107 is indicating sea level pressure. The pressure trend is sometimes noted on it. Then over on the left side, these are the ones I most look at, of course. We have temperature in Fahrenheit. You have the dew point in Fahrenheit. And then you see those three little dots? That is indicative of the current weather conditions if it is doing something notable, like raining, or if it's snowing, or if it's foggy. So these little symbols will tell you what's happening at that particular station. So this is kind of a key. And it even tells you the intensity. So like right now, I know outside my house, I think it's still like drizzling. So we probably have like maybe just 2 dots on our surface weather data. If it were snowing, you'd have kind of these little, they're like little asterisks. This is the weather symbol for thunderstorm or shower, drizzle. Actually, there's drizzle, so we might have kind of those commas at my house. There's freezing rain, there's ice pellets, there's fog. So these straight lines here are fog. And there are actually a handful of other weather surface data symbols out there. As far as the wind goes, we do use wind barbs, and the wind barbs are pointing in the direction that the wind is coming from. So like this one here is showing a northeast wind. This one here is showing a west wind. And the little barbs and the flags will tell us how fast the wind is moving. So if it's a little half bar, that's 5 knots. If it's a full bar, it's 10 knots. And if it's a flag like that, I believe it is 50 knots. And then calm winds are noted by that little circle there. All right, so how about we find some fronts? Let's see what is happening in real time. So this map here is what we call a surface analysis. And this one is done by the National Weather Service, but also the WPC. Now you can find this. The website is wpc.nsep.noaa.gov. And I will probably post that link for you to help if you want it after. But even if you just Google NSEP surface analysis, you'll be able to find it. But of course, we talked about the red L's. So that indicates low pressure. And there's a couple of low pressure systems off of the coast now, which is not surprising because we here in New England had some really unsettled weather yesterday. We had a storm system move through. Looks like there's another low pressure system noted in the Great Lakes region, and then a trailing cold front behind it. Big area of high pressure in like the middle part of the country. And it looks like maybe a cold front that becomes a stationary front down along the Gulf Coast. So I kind of just gave it away a little bit. We should have looked at this map first. But what we're going to do is, this is a map here of the Northeast. And these are all of those weather stations I was talking about. And all of the different data. So since, many of you are watching from New Hampshire, we'll kind of take a look. So Concord right here, it has a blue dot, which means it's completely overcast. Not seeing any breaks in the clouds. And then it looks like there's a northeast wind and it's a full bar, so it's probably around 10 knots. We look at Portsmouth and you see these double lines here. Those are indicating fog. And it looks like there's fog also reported in Boston, Manchester, and also Keene, it looks like, and down through Cape Cod. Cape Cod here, right at the very end, Provincetown, that G25 means that's a gust at 25 miles per hour. But the key here is that the winds, for the most part, are coming out of the northeast. So it's helpful to look at the winds to see where there might be a low pressure system. Or a high pressure system. I typically look at the wind direction and to some extent the wind speed, to find out where high and low pressure systems are. And it's actually pretty evident where we have the high pressure to our north. See how this wind barb this is south, this one's pointing to the east, and this one's coming out of the north. So it looks like we have the winds in kind of this clockwise motion up here. So that's likely where we have maybe a localized high pressure system there. Then I look at differences in temperature to try to find frontal systems too. It does look like there is some precipitation, like in Syracuse, New York, Buffalo, New York, those double dots indicating light or moderate rainfall. I'm going to switch to go over to the Great Lakes region, and this also will give us some help in finding different frontal areas and high pressure areas. So what's pretty interesting too is you definitely can see a difference. There's definitely a cold front here, probably between, say, northern Maryland and then Pittsburgh. Because you see Pittsburgh, it's 49 degrees. And then in northern Maryland, it's 62. And there's a wind direction change. So that's a sign that there is some sort of change. There's a boundary there. And it likely is maybe a secondary cold front here. And then we do have the winds, looks like coming right out of the northeast here. So that big high pressure area to the north, it looks like it's driving some of these winds around. So essentially I look at the wind direction, I look at change in temperature, the sky condition too, to help give me an idea of what we have going on with the weather, where we have these fronts that have set up. So looking in the southeast, and primarily they have winds kind of coming out of the northeast, but then they shift to be more out of the east here. So there's likely probably an area of high pressure, since it looks like the winds are moving in this clockwise motion down here. Yeah, I would say probably somewhere in here we've got our little area of high pressure, just based off of the wind movement. All right, so that's a look at how I analyze surface weather maps and some information about fronts and high and low pressure. So I see a couple of you with questions and comments here, so I'll jump through those really quick. Jennifer saying hello from Iowa. Hi. Beth asking, when will the rain stop? Hopefully the grandsons on Wednesday can go outside. Yeah, so we can actually kind of talk a little bit about that. What I like to use is a radar to look at precipitation. And let's kind of take a look at what's happening. So the rain that we have over New Hampshire, I assume that's where you are, is really fine. It's that drizzle. It's very light. So because of that, it's not really showing up all that much on the radar. There's barely anything showing up. But there is definitely kind of that drizzle going on. And there is some more rain off toward our west, even some snow showers. So we are not done. Today is going to be kind of a damp day. But I think by tomorrow, for the second half of the day, and Wednesday, it should be pretty dry. I use a couple different programs to look at the forecast. What I'll do is I'll bring up one of our models here. This is the American model. Might be a lot to look at, but so here's New Hampshire right here. And so let's see. So this is Wednesday morning. So yes, it looks like we do kind of clear out a little bit. There might be some snow showers in the North Country, but at least much of Wednesday does look dry. Then as we move into Thursday, we are under the influence of this low pressure system that's off the coast of the Canadian Maritimes, and it continues to drag down just this maritime cold air. I know we talked about air masses. And so when I say maritime cold, it means it's basically coming off the ocean. And so you get that raw, chilly feel, below average temperatures. And so that is around Thursday. It looks like Friday we finally that system pulls away. And the weekend looks brighter, but not necessarily, well, maybe a little bit warmer. But you've got those big blue H's. This is Saturday afternoon, big blue H. So that's indicating there will likely be some sun. So at least the first part of the weekend does look dry. And then progressing into Sunday, maybe some late day showers or even snow showers. Looks cool enough, especially in the mountains, for that to happen. Janelle saying good morning from Fremont. Hello. Esther saying good morning. Judy saying love the straight hair. Thank you. Didn't have time to curl it this morning. Brenda saying good morning from Chester. Shirley, good morning. Albert, Pablo, Al. Walter saying I should sing. I don't know about that. Terry says love your hair straight. You look like a teenager. Thank you. Andrea saying good morning. Rich saying I think the fronts crashed together last night. That was actually a cold front that went through. We typically get those when you get thunderstorms like that. Those can be some stronger cold fronts. Lynn saying good morning. Nora asking a great question. What do the different colored dots mean on the surface air map? Good question. So let me bring that up really quick. So I believe that is indicating a change. You know, I actually am not fully sure what the different colors are indicating here. I'm gonna have to get back to you on that because I think green is trying to indicate at a quick glance that it's clear. Yeah, so then when you get into blue and reds, I believe it's just trying to note that there's been a change of some sort. So meaning it might have been raining it, or the clouds are increasing, decreasing. But honestly, I need to look that up. It's a really good question. It's not something that I have really seen all that often. So I'll get back to you on that. It's a great question. Anne saying good morning. Al says, even with your explanation, I still can't grasp what the maps are saying. I guess being a meteorologist takes more than a 30-minute study. Yeah, it definitely does. I took a whole class in college on essentially weather analysis and data. So we would actually we would draw, like we would print out maps like these and we would have to draw the fronts on. We would call that doing our own surface analysis. And somebody is doing that here. They're literally drawing on that L, of course with a computer, but someone, and even the name of the meteorologist on this, see their analyst, Kebede, did this one this morning. So it is a job that some people do. And it was something that I did in college where I would study the surface analysis here and would be able to grasp it. But it's a lot of data, and that's why I have a job, right? It's kind of to be the interpreter for you as to what these maps are saying. So I love looking at maps. It's one of my favorite parts of the job, and analyzing maps like this, it is kind of, to me, it's really fun. The last question I'll take is from Lisa, and she asked, do air masses move? And the answer is yes, they definitely do. Air masses are actually constantly moving across the globe, and it's very fluid. This map of the air masses kind of shows like the default areas of air masses, but they are constantly kind of getting pushed into each other. And this is happening mainly due to winds and also differences in pressure, which really is wind. So when you have differences in pressures, the high and the low pressure, that creates the wind. So when you have maybe a high pressure system in this continental polar area moving down toward New England. It's kicking out the maritime polar. So that difference as the wind is pushing the air mass around causes those fronts to form and storms. So, so Lisa, the answer is yes. The air masses definitely do move, and it's typically because of pressure differences and wind. All right, that's all I've got time for today. I really I thank you all so much for watching and for your questions, your comments. If there are more, I will be sure to go back and look. I'm going to get an answer to those dot question too for you. But thank you all so much for watching, and I hope that you enjoy the rest of your day. Take care.